What is Energy Efficiency Design Index? 90% of the world's trade depends on international shipping. Emissions from ships are a matter of grave concern that the most extensive transportation and logistics sector has been grappling with for several years. As per estimates, carbon-based emissions from vessels account for 2 to 3% of the net global emissions. They are expected to rise manifold in the next few decades by 50 to 70%. Nitrogen oxides encompass a whopping 20 to 30% of the global share, whereas sulfurous gases contribute roughly 10% to the net emissions. Thus, the International Maritime Organization strives to decrease maritime emissions for the prevention of air pollution by introducing new guidelines. EEDI. The Energy Efficiency Design Index is a non-prescriptive mechanism that allows the shipping industry to use the latest technologies for designing commercial vessels as long as they meet the required energy efficiency levels and parameters. EEDI lays down a minimum energy efficiency level, per capacity mile for different ship types and sizes. Energy Efficiency Design Index and SEEMP were formulated by IMO as amendments to its interim guidelines MARPOL Annex VI at the 62nd Marine Environmental Protection Committee meet, Resolution MEPC 62, in 2011 and enforced from January 2013 onward. From the 1st of January 2013, newly constructed ships had to meet the level for their ship type. The carbon dioxide reduction level for Phase 1 is 10%. Every 5 years the EEDI level would become stricter to boost innovation and technical development and reduction measures, ultimately influencing the fuel efficiency of a vessel right from its design phase or the initial design stage. EEDI components. It is estimated using the EEDI formula, which calculates the vessel's County 2 emissions per unit of transport work done while in service. Now, this EEDI has two components. 1. Attained EEDI. 2. Required EEDI. A complex formulation is used for calculation and verification of the vessel's attained EEDI based on technical factors related to the type, cargo capacities, ship speed, hull type, main engine, turbine, propulsion, fuel, service information, DWT, etc. EEXI. EEXI is another historic milestone fostered by IMO after the adoption of EEDI. It highlights the vessel's emission rate and its propulsive efficiency. It is then compared with the required EEDI, calculated on empirical and statistical relations as mandated by IMO and other classification bodies based on vessel data and pollution scenarios. For all practical purposes, the attained EEXI needs to be lesser than or at most equal to the required benchmark. If somehow, this attained value exceeds the required, the vessel is said to fail in terms of energy efficiency and is not deemed fit to ply in the seas. Now, a natural question arises: if such norms exist for new vessels, what about existing ships, which as a matter of fact, emanate more amount of pollution due to their age as compared to new ships? Though somewhat late in its advent, EEXI is an answer to that. The Energy Efficiency Existing Ship Index, EEXI, concept was broached up in the MEPC 75 of IMO held in 2020 with an agenda to make significant changes to the crucial Annex VI. The final target is to achieve the idealistic zero emissions towards the end of the century. The main objectives of MEPC 75 were to introduce two crucial pillars, EEXI and Carbon Intensity Indicator, the CII. EEXI is essentially a technical measure, and CII is an operational measure. For all practical purposes, EEXI is the same as EEDI, with one difference. The former is applied to all existing ships above 400 GT. Formulation of EEXI. Like EEDI, attained EEXI needs to be less than or equal to required EEXI. The formulation of attained EEXI varies from vessel to vessel, of course, and can be simply summarized as the carbon emissions per unit weight and unit distance traveled. Attained EEXI equals Carbon dioxide conversion factor x specific fuel oil consumption of engines x engine powers. Cargo or tonnage capacity x speed. The carbon dioxide conversion factor is based on the grade of fuel oils used. Specific fuel consumption is the amount of fuel expended in unit work. This is obtained by the power generated in kW multiplied by time. For all practical purposes, the capacity or tonnage is taken as the deadweight, with only one exception for container ships, where it is to be taken as 70% of the net deadweight. Similarly, speed and engine power are to be calculated at 75% of the maximum power rating of the engines. Like EEDI, the required EEXI is based on empirical reference lines for the vessel. If attained is within the required limits, the ship is said to be EEXI compliant. Thanks for watching, and we'll see you in the next video. Like, share and subscribe.